Assalamualaikum. Assalamualaikum.
Hello.
Assalamualaikum.
Assalamu alaikum.
Walaikum Assalam. Is my voice is clear?
Yeah.
Okay. How are you?
Good.
I hope everything is going well over there.
Yep.
Okay. So have you did what I gave you in last lecture, the assessment?
Uh, uh, yeah.
Okay. Is there any problem with those problems?
Uh, no, not really.
Okay. So
They're
do you
all
solve all those
straightforward.
three problems?
Yeah.
Okay. Sure. You haven't shared me the PDF of your last assessments?
Oh, my mother still needs to send you them. She will send you them today. She will.
Sure. Okay. So if there are no questions, let's start our today's lecture number 5. Let me share my screen with you. My screen is sharing with you.
Yeah.
Okay. So today is our lecture number 5. And in this lecture, basically, we will discuss about free fall, the action of bodies under the free fall, and we will also learn about what are vertical motions. You know what we did in our last lecture, we solved the main three equations of motions. Do you
Mm.
remember those three equations of motions?
I think so. Yeah.
Okay, how many equations of motions are there?
Uh, three.
Yes, three. So basically, if you remember those equations of motions, we will again use those equations of motions in our today's lecture also, okay? Because this lecture is also relates to the previous lecture. So this lecture is basically about the bodies which are going under the action of free fall, okay? And we will also discuss the
Okay.
vertical motion. What are vertical motions? So here are our learning objectives. So first of all, basically we will understand the motion under gravity, okay? And you know that gravity always attracts or repels.
Mm-hmm. Attracts.
Yes, gravity always attracts each other. And what is the motion of, you can say, of dead bodies? They're downward or upward?
Uh, Downward.
Yes, downward. Whenever we are concerned with the gravity, gravity always attracts bodies and they move bodies downward. Okay, we will understand the basically motion of gravity and we will basically check what are the motion of your bodies. Either they are uniform accelerated motions, either they are variable accelerated motions. We will discuss it later, and then we will apply those equations of motions what we did in our last lecture. What we have to simple do is that Wherever there is a acceleration, we would replace that a with g. Understood? In your
Mm-hmm.
equations of motions, what we learned in previous lecture, wherever there is a, we just replaced a with g, because we know that a is basically the acceleration, whereas this small g represents the gravitational acceleration. All right.
All right.
Yes. If just visualize that if bodies are moving, you can say that bodies are accelerating. Okay. And again, you told me that under the action of gravity, bodies move downward. So if bodies move downward, again, it means they are accelerating. So if bodies are moving under the action of gravity, this type of acceleration is called as the gravitational acceleration, and this gravitational acceleration is denoted by small g. All right,
Mm-hmm.
and the value of this small g is 9.8 meter per second square. Keep remember this constant value.
All right.
Okay, then we will also use appropriate signs for upward and downward motion. We will see what the sign we will use if body is moving downward, and what sign we supposed to use if body is moving upward. We will discuss later, okay? And then after we will solve problems related to involving maximum height. Maximum height is basically the top height that your body achieve. And then we will discuss the time of flight. Basically, time of flight means the total time your body takes from starting point to end point. And we will also solve the problems related to impact velocity. Okay, impact velocity basically means what is the impact of velocity. You know that body has two type of velocities, either initial velocity or final velocity. All right.
Mm-hmm.
Okay,
Yeah.
so let's discuss the first section, which is acceleration due to gravity. As I told you, in gravity, your body is moved downward. If bodies are moving downward, it means they are accelerating. And if they are accelerating, then this can be defined as this is called as gravitational acceleration. So here is the definition how you can define the acceleration due to gravity is that acceleration due to gravity is the rate at which your object accelerates either downward or upward. Okay, but for the case of gravity, it's always downward. Okay, acceleration due to gravity is basically the rate at which your objects accelerate when falling freely under the influence of the earth gravitational pull. You know that gravity always pushes your objects downward.
Mm-hmm.
And if your gravity is pushing your objects downward and your objects are start accelerating, this type of acceleration is called as acceleration due to gravity, or you can use a specific name which is called as the gravitational acceleration. But the fact is that you must have to ignore the air resistance. Okay?
Mm-hmm.
Yes. As I mentioned you before, acceleration due to gravity is denoted by small g. Okay, this small g, and the standard value of this gravitational acceleration is 9.8 meter per second square. This is the value of gravitational acceleration on Earth. Okay,
Mm-hmm.
your gravitational acceleration varies from different planet to planet. Okay, but we remains on Earth, and the Earth's gravitational acceleration is 9.8 meter per second square near the surface of the Earth.
Mm-hmm.
Sometimes we use the approximated value like 10 meter per second square for our easy calculations. You can use both
Mm-hmm.
9.8, or you can also use 10 meter per second square.
Mm-hmm.
And now, as I told you, there are two types of motion. Either your body is moving upward or either your body is moving downward. Okay. But in the case of gravity, your acceleration is always vertically
Downward.
downward, because gravity always pushes your objects downward. Okay. Pulling all objects towards the center of the earth. And you know what is the origin of the gravity? The origin of gravity is the center of the earth. All right.
Mm-hmm.
Okay. An important thing is that your gravity, or you can say your gravitational acceleration, is independent of mass. Means it does not depend on mass. Means if you have a small mass and if you have a large mass, if you throw both masses with the same height, both will reach at the bottom point at the same time. But the fact is that you have to ignore the air resistance. If there is air resistance between those objects, then your heavy mass object will reach first and low mass object will reach after. But if you ignore your air resistance, means if there is vacuum, there is no air inside. And if you throw two objects of different masses, one of high mass and one of low mass, both objects will reach the bottom at the same time. Okay? Because we know that your gravitational acceleration is independent of mass. It does not depend upon mass. All right?
Mm-hmm.
Okay. Any question regarding this?
No.
Any question regarding this?
No.
Okay. As you know that there are three equations of motions, and what I told you before, uh, you have to just replace your A with the G, because
Mm-hmm.
acceleration also means your gravitational acceleration. Because we are concerning with the gravitational acceleration, then you have to replace your A with the G in your equations of motions. Okay,
Mm-hmm.
we have to use positive G whenever your object is falling downward under the action of gravity. And whenever your object is moving upward, means against the gravity, you have to introduce minus sign. This is important. You have to understand.
Mm-hmm.
Okay. If your body is falling under the action of gravity, which sign you have to use?
Uh, Positive.
Yes, positive. And if your body is moving against the action of gravity, then you have to use?
Minus.
Yes, minus sign. Okay. And you also know that at the highest point in an upward motion, the velocity becomes zero. And just suppose that you throw a ball upward. A ball must reaches a maximum point, right?
Mm-hmm.
At the maximum point, what is the velocity of the ball? Can you tell me?
Uh, Zero.
Yes, zero. Because you uh, threw a ball upward with some initial velocity. Let's suppose it's 10 meter per second. But at the very highest point, the ball may remain stopped for some milliseconds. At the just top point, your velocity becomes zero, and again your ball moves downward under the action of gravity. Again, it attains the velocity, but at the highest point, your velocity becomes zero for a while.
Mm-hmm.
And when it becomes zero, again, because there is gravity would act on your ball. So then your ball again moves downward under the action of the gravity, because your gravity now pushes ball downward.
Mm-hmm.
That's why bodies fall downward if you move upward. Okay.
Yeah.
Okay. Any question?
No.
Okay. So here are some key points which you have to remember. Those key points are basically you have to learn that objects drop from rest. You know that this small u basically means initial velocity or final velocity.
Uh, the final.
U means, I think, initial velocity,
Oh,
and v means
final.
the final
Final.
velocity. Yes. Next. if your object drops from rest position, means you are dropping your object from rest position. So definitely the initial velocity would be,
0.
yes, zero, because you drop your object from rest. Whenever there is a rest means your initial velocity should be zero. So this means your object be in motion without any initial velocity. Only gravity accelerates. Okay. Example is in front of you is that pick up a ball in your one hand, move that ball upward, and the ball in your hand has initial velocity. And whenever you open your fingers, your ball will move downward under the action of gravity. You haven't gave the ball some initial velocity, but the ball moves under the action of gravity. Okay, so this is basically whenever your object is at rest, it means their initial velocity would be zero. And this I already told you at the very maximum point, at the very highest point, your now v becomes zero. V, which is the
Hmm?
this v is basically the
Initial.
v.
Oh, final. Final.
Yes, final. Because you have to throw a ball with initial velocity, and at the very highest point, the ball reaches the final velocity. Okay, so it says about the highest point, maximum height that your object attains. At the very maximum height, your final velocity would be zero, because I told you that there is a movement at the very maximum height point where your object just stops for a while, and then after they move under the action of gravity.
Mhm.
That's why their final velocity must be zero at the very maximum highest point. Alright?
Mhm.
Initial velocity is zero at the starting point, and final velocity is zero at the maximum point. Alright?
Mhm.
Okay. Then basically we will discuss the direction of acceleration. You know that gravity always acts downward, okay, whether the object is going up or going down. If you move an object downward, it will move downward with the speed. And if you move object upward, again your object will undergo under the action of the gravity. Gravity always pulls your object downward. Okay, gravity works everywhere.
Mhm.
And this sign, I already told you that you have to take positive G whenever your object is going downward, means under the action of gravity. And you have to take minus sign with your gravitational acceleration when your object is moving upward, which means against the gravitational acceleration.
Mhm.
Here are your equations of motion, what we discussed in our last lecture. V equals to u plus at. Do you remember this first equation of motion?
Uh, is that to find the velocity?
Yes, final velocity equals to the initial velocity plus at. A, which is the acceleration, and time, which is the t. And here is the second equation of motion. S equals to ut
Uh,
plus half at square. And here is the third equation of motion. V square plus u square plus 2as. As I told you that whenever there is no time mentioned, you have to use third equation of motion, because in third equation of motion there is no time. And
mhm.
whenever there is time in your problem, you have to use either first or either second. If they ask you to find the total distance, you have to use second. And if they ask you to find the initial or final velocity and time is given, you have to use the first equation of motion. But
Mhm.
these, what we have to do is here, wherever there is A, here you can see A, here you can see A, and here you can see A. So in all three equations of motion, you can see A, which is the acceleration. What you
Mhm.
have to do is simply replace this A by,
Uh,
you have to replace this A
moving it to our side.
by G,
Oh.
small g. Understood?
Mm-hmm.
Because we are discussing the gravitational acceleration. As I mentioned you before, A is only the acceleration. Your objects are moving. But we
Mm-hmm.
are learning about the gravitational acceleration. Gravitational acceleration is also your bodies are in motion, but under the action of gravity. So you have to replace this A by G, this A by G, and this A by G. Okay?
Mm-hmm.
Okay. It would be clear whenever we are solving examples. So here are our worked examples in front of you. Let's solve some practical examples. Here is our example number one. A ball is dropped from a height and hits the ground after 4 seconds. Find its velocity just before the impact. So if your ball is dropped from a height, so can you tell me what is the initial velocity of that ball?
Uh, 0.
Yes, because a ball is at rest position on some height and ball is dropped from some height. There is no initial velocity is given. So if not given, so it means the initial velocity of the ball is zero. Okay?
Mm-hmm.
And if the initial velocity of ball is zero, can you tell me how that ball moves downward?
Uh,
Because
no
if there is
change.
no velocity, because if there is no initial velocity, your objects would not move. But here you can see your initial velocity is zero, but your
Mm-hmm.
ball is moving and reach the ground. How this happens? Can you tell me?
Gravity.
Yes,
Gravity pulls
gravity.
them.
Yes, gravity. Because you know that gravity always pushes your objects downward. So
Mm-hmm.
if there is no velocity even, your objects move downward. That's good. So here is the initial velocity is zero and time which is given 4 seconds. They are asking you to find the velocity. It means they are asking you to find the final velocity just before the impact. Means impact on ground. So you have to find the value of p. So can you tell me if time is given and asking you to find the final velocity, which equation of motion you have to use?
Uh, the first one.
Yes, the first one. Good. So here is your first equation of motion. V is equals to u plus gt.
GT.
Okay.
Mm-hmm.
A is replaced by
G.
g. Why g? Because now your ball is moving under the action of gravity.
Gravity.
Now your acceleration becomes gravitational acceleration. All right.
Mm-hmm.
And the value of this g is not given. But I mentioned you before, you have to learn the value of g, which is the constant value, which is 9.8
Mm-hmm. 8.
meter per second square. So simply just putting the value of u 0 plus
Mm-hmm.
g 9.8 t4, just multiplying, you will get your answer, and which is 39.2 meter per second. Means if you drop a ball with some initial velocity which is zero,
Mm-hmm.
gravity under the action of gravity, your ball will hit the ground with speed. Okay,
Mm-hmm.
understood? Any question?
No.
Okay, let's move towards another example. Example number two. A stone is thrown vertically upward. Okay. Now
Mm-hmm.
in this problem, you will throw stone vertically upward with 20 meter per second square. Okay.
Mm-hmm.
Now can you tell me this 20 meter per second is what? Which velocity, initial or final? Because you throw stone upward.
The initial.
Yes, initial velocity. Okay. You must
Mm-hmm.
have to apply velocity if you move objects against the gravity, because if you are throwing stone upward, it means you are moving some object which are against the action of gravity, right?
Mhm.
So in this case, if initial velocity is zero, your object would not move upward. You must have to apply some value of initial velocity to move your object against the gravity. So this is basically the initial velocity. So you can see u is equal to 20 meter per second. Because your stone is thrown vertically upward, there is a time at which your stone just stops. So the at very highest point, can you tell me what would be their final velocity?
Uh,
At the highest point, what is the final
Zero.
velocity? Yes, zero. Because at the highest point, your body will stops for a while.
Mhm.
Yes. Okay. So that's why you can see here v equals to
Zero.
zero. And they are asking you how high does it go? Basically, what they are asking you to find the distance. How high does it go? Means from starting point to the highest point, you have to find the total distance covered by the stone which you throw vertically upward. They are asking you to find the distance. So, can you tell me for finding the distance, which equation of motion you have to use if there is no time given?
Third one.
Yes, third one. Because in third equation of motion there is no time. You can use second equation of motion, but there is time. But in this problem there is no time given, so we cannot use second equation of motion. We will move on towards the third equation of motion. So here is our third equation of motion. What you have to do is now just put in the values. You can see the value of u, which is 0, equals to u square, means 20 square. 20 square becomes 400
Four.
plus 2a. Okay, and this replaced by g, here should be g. And what is the value of g here?
Negative 9.8.
9.8. But can you tell me it's positive or negative?
Negative.
Why negative?
Because the ball's being thrown upwards.
Yes, because stone is thrown upward, which is against the action of gravity, right?
Mhm.
Yes, that's why this negative sign you have to introduce by yourself. Okay, just substitute these values and you will get your answer, which is 20.41 meters. So this is how you can find the distance if you throw a stone upward. Any problem?
No.
Okay, let's move towards the third problem. A ball is thrown upward. So by this statement, can you tell me you are moving against the action of gravity or you are moving under the action of gravity?
Against.
Yes, against. A ball is thrown upward with a velocity of 15 meter per second. Again, this is which velocity? Initial or final?
Initial.
Yes, initial velocity. So that's why you can see u equals to 15. How long does it take to return to the thrower? How long does it take? Means they're asking you to find?
Time.
Yes, time. So now you have to find the time. And again, your ball is thrown vertically upward. So if the initial velocity is 15, their final velocity must be
Zero.
0 because your ball will stop for a while at the very highest point, right?
Mhm.
Again, you have to find the time, the total time that your ball takes. So if initial and final velocity is given and they're
Mhm.
asking you to find time, which equation of motion you have to use? In which
Uh,
equation of motion there is final velocity, initial velocity as well as time?
the second one.
In second one, there is s. It means you must need distance. So there is no distance given in this problem. So you have to move on towards another.
Is the first.
Yes, the first one. Okay. This is your first equation of motion, right?
Mm-hmm.
What you have to do, you have to find time. First, you have to move this u to the other side, so it
Mm-hmm.
becomes v minus u. So you can see v minus u here. Okay.
Mm-hmm.
And you have to find the time. So this a divides to the other side. So that's why you can see this a divides to the other side. So the equation of time becomes v minus u divided by a. Have you understood?
Mm-hmm.
Okay. Now by just putting the values, you will get your answer, which is 1.53 seconds. But what you have to do here, you have to multiply by it 2. Why 2? Because they are asking you to find how long does it take to return to the thrower. This time is basically to reach at the highest point and the same time it takes to reach to the thrower. So you have to multiply your answer by 2 times. So you will get your total time that your ball takes from thrower to thrower. All right?
Mm-hmm.
Okay. Any question?
No.
Okay. So here is our fourth example. An object is dropped from a height. So from this, can you tell me this is against the gravity or under the action of gravity?
Under the action.
Yes, under the action of gravity. And takes 5 seconds. Means time is given, which is 5 seconds to reach the ground. Okay.
Mm-hmm.
Again, your object, if your object is dropped from some height, their initial velocity would be
0.
0. And what they're asking you to find the height. Height means you have to find the distance. Okay, they
Mm-hmm.
can use same words, height and distance, both remain same. Okay,
Mm-hmm.
so if time is given and they're asking you to find the distance or height, which equation of motion you have to use?
The second one.
Yes, the second one. This is your second equation of motion, just putting the values u, which is 0, okay, and time, which is 5. So 5 multiplied by 0 becomes 0.
0.
1 by 2 gt square. G not given, but you have to use
Uh,
9.8 because in this your ball is dropping downward. So you have to use plus 9.8 or negative 9.8.
plus.
Yes, plus. That's why I use plus 9.8 here. And time square. Just
Mm-hmm.
substitute your value, you will get your answer, which is 122.5 meters. So this is basically the total height that your object. Okay,
Mm-hmm.
understood?
Yeah.
Okay. So our last example. What is the velocity of a stone just before hitting the ground if it is fall from 30 meter? What is the
Mm.
velocity of a stone just before hitting the ground? So what does it mean? You have to find which velocity, final or initial.
Final.
Yes, before, because it says just before hitting the ground. It means you have to find the final velocity. It means you have to find the v, and this is given. The hitting the ground if it falls from 30 meters. This 30 meter is what?
The distance.
Yes, the distance. So if there is no time given and distance value is given, which equation of motion you have to use?
The third one.
Yes, the third one. So here is your third equation of motion. Okay,
Mm-hmm.
v square equals to u square plus 2as. A is replaced by g.
G.
Okay, so 2gs it becomes, because your stone again their initial velocity would be 0, so you have to just substitute these values. U becomes 0 and 2gs 2g,
Mm-hmm.
because now your ball is just dropping and hitting the ground. It means your ball is moving under the action of gravity, so you have to use plus 9.8, right?
Mm-hmm.
So 2 multiplied by 9.8 multiplied by distance, which is 30. So you will get 588. But here you can see v square. You only need the value of v. How you can remove this square? By taking,
Square root.
yes, by taking square root. By taking square root on both sides, You have to take square root of 558. You will get your answer, which is 24.25 meter per second. Okay. Any question?
Mhm. No.
Okay. So this is the table which I already told you. If your object drops from rest, you have to use your initial velocity 0. And if your object is thrown upward, okay, then your velocity must be positive, okay. And if your object is downward, this means again positive, or you can say 0. But at the very maximum highest point, your final velocity would be,
Zero.
yes, 0. And if your object starts from, your acceleration would be positive. In what case? If your objects just fall downward, or if your objects drop from rest. And if you throw your objects upward or at the very maximum highest point, your gravitational acceleration would be minus. Okay.
Mhm. Yeah.
uh, these are the same worked examples what we did. This is okay. So
Mhm.
here is some quiz for you. So can you tell me what is the value of g near the surface of Earth?
9.81 meters per second squared.
Yes, wonderful. Can you tell me what is the velocity of an object at the top of the motion?
0 meters per second squared.
Yes, good. So can you tell me how long will it take a ball to fall 20 meters from rest? So this problem you can solve by which equation of motion?
Um,
Which factors
second
are
one.
given? The distance is
Okay.
given,
Time. Mm,
okay? And they're
second.
asking you to find time. So which equation of motion you have to use?
Second one.
Yes, second one. Okay. So by using second equation of motion, you can solve this problem.
Mhm.
And can you tell me, an object falls from 3 seconds, what is its velocity just before hitting the ground?
29.4 meters per second squared. Meters per second, sorry.
Yes, by what equation of motion you have to use?
Third one.
The first one?
No,
Yes, the
both.
first one. Okay.
Yeah.
In first one, the initial velocity is 0. That's why Vi is 0. U, basically the formula is V equals to U plus GT.
Mm-hmm.
Why there is no U? Because the initial velocity is 0. Okay.
Mm-hmm.
If initial velocity is 0, only remains GT. So by putting the value of g, which is 9.8, and putting the value of time, which is given 3 seconds, so 9.8 multiplied by 3 becomes 29.4 meter per second. Okay,
Yeah.
perfect. Any question?
No.
Okay, so here are some 3 problems for your homework. You can solve and send it to me till
Mm-hmm.
next class, next lecture. Okay,
Alright.
so any question regarding today's lecture? We discuss
Uh,
about the gravitational acceleration.
no.
Okay. Do you prepare these lectures at your home?
Yes.
I shared the PDF with you of these lectures.
Yeah.
Okay, so you can revise. Okay.
Okay. Thank you. Right.
Thank you. Take care and Allah Hafiz.
No fish. Right. Bye.
Allah Hafiz.